Well, thank you so much for giving me the opportunity to talk today. Yesterday morning, you heard a lot from the mission architecture standpoint and what kind of the regional and site considerations were for making these missions operational, things like comm and lighting and that sort of things. So I'm kind of doing a subset of that, and this is for longer term sustainability. And I'm going to be talking to the ISRU considerations, so the in situ resource utilization considerations to the region and the site selection. So just to put that in context and kind of add that into the bucket for considerations. So you might be saying, why the heck am I talking about ISRU now for Artemis 3, right? ISRU is not planned as an implementation within Artemis 3, but we are in the bigger picture, right? So if you look at the NASA sustainability plan, if you look at the Moon to Mars objectives, right, there's lots of language in there regarding implementing this and long-term economies, industrialization, of involving ISRU. And you can see I pulled out some specific Moon to Mars objectives there that call out ISRU and working towards that, as well as the science, the applied science that needs to happen before we do the ISRU, specifically AS3, where we talk about characterizing the resources and then identifying the reserve or a usable deposit that we can use for ISRU. So if you look at this from the bigger standpoint, the early Artemis missions are really key to part of the key to understanding ISRU technology development, doing that development demonstration, but also doing that resource assessment and understanding that. And if you look at the bigger picture, we're still working on the different asset placement for Artemis in terms of long-term utilization. So what you put down in Artemis 3, when or is that going to be reused, and how is that going to fit into the bigger campaign and the bigger Artemis utilization? So if you consider ISRU from the beginning and have that option available to you, um, you can reuse those assets more effectively. You can leverage ISRU to help extend your range, extend the usage, and be able to leverage ISRU assets as well. And I sort of put this manifest on there as it was presented publicly in December, and you can see that there's an ISRU pilot plant out here in the mid or later Artemis campaigns, and then early on there's opportunities and some early CLIPS missions for ISRU demonstrations. All of this could be leveraged as part of this. So really, I'm talking about ISRU as a campaign consideration. Go ahead to the next slide. I don't think I need to spend much time on this with the big group, but just to say this acknowledgement that exploration, it's not exploration versus science, it's exploration and science, right? We can choose regions that are mutually beneficial. There's a lot of overlap in the needs of the different communities. There's some specific focus, so there's some elements that aren't overlapping, but a lot of it is. So we can really consider this, and I think this whole workshop is kind of focused on this. So again, resource assessment, we benefit from all the information that comes back, right? Feeding into geostatistical models and really understanding the map and where the resource is. So whether it's CLIPS or orbital data or whatever. But when you're talking about the large asset placement, it's even more beneficial to consider and choose regions that have the viability to support ISRU architectures that have that reserve potential. Not only so you can do that resource assessment, but then have the opportunity to turn that into your ISRU opportunity. And then go ahead to the next slide. So, getting into what our considerations are for early ISRU, and by early ISRU, I mean these earlier Artemis missions, not that big industrial economy, but the foothold kind of ISRU. We're talking about production of large mission consumables, mainly propellant, for early ISRU. We're going to have limited infrastructure in terms of power availability, civil engineering opportunities for roads or being able to transport resources or product in different ways. And again, with that is the mobility assets being restricted to what we're going to have available to us there, what kind of human robotic interaction for maintenance or transport. So that's kind of what we're talking about for early ISRU. We're also talking about, in context here, specifically about water ISRU, where oxygen from regolith or extraction from the mineral resources is still a possibility and it's still in the picture, but keeping in mind that doesn't close the loop on the propellant for the fuel production. So really what we're talking about here is the water to close that loop. And then we're also focused on, at least for the early missions, the top 1 meter surface deposits. So something within the top 1 meter, just for the early technologies that we think we're going to be able to implement. So really, we're talking about PSRs in this picture. Okay, get to the next slide. So, what are the considerations that fall out of that? So, I talked about production scale, and cadence. So, we're talking about tens of metric tons of propellant produced in 1 year. And we're talking about, Artemis, what we got Artemis through 7 or 8 currently in that manifest. So really that goes to the tonnage that we're looking for. And the punchline here is that smaller PSRs, even only a few kilometers in diameter, are adequate for the early Artemis. And then as we scale up, that gets us our foothold. And then as we scale up, we might be looking for larger deposits. But for early Artemis, these smaller ISRUs should be adequate for us to leverage. For infrastructure, we talk about power. We're probably going to have to leverage solar power for at least a portion of the ISRU system. Where again, we're going back to the same thing you heard yesterday, where illumination is important and the proximity of that illumination site to the mine site, but also to your customer, your Artemis customer, whoever is going to be using your product. Those are kind of restricted by the mobility assets, which feeds into the next one. So we're probably going to have to use conventional mobility for this. So again, we're talking about not only the proximity or the distances between these different assets, but also the terrain considerations, things like slope. So those are kind of the big picture considerations going into ISRU. Next slide, please. So we did do an initial case study just to see how these criteria fit with the initial 6 sites. So this was from the Artemis Sustainability Plan, not all of the Artemis 3 sites, but as a starting point, just to see how things fell out, see how these criteria applied, and then also to kind of massage that to see what capabilities would be enabling or to make this happen or make it more possible. So again, the idea here was to look at criteria from an ISRU implementation perspective beyond just tonnage alone, and look at the Artemis capabilities and what we think we're going to have for those early campaigns. So again, it's going to evolve as we get more information. And I do want to stress that we do recognize other value evaluations have been done for the tonnage considerations and even with some ISRU considerations. But really, what we fell out here is a smaller PSRs, recognizing that our knowledge gap in those is bigger, or confidence level at this point is not as great for those smaller PSRs. So that was kind of the focus of this study as a baseline. Next slide. We kind of had to go into it with an ISRU architecture in mind. This is one example. There's others on the table, but in this circumstance, we're talking about going into a crater for a PSR, doing the water extraction at that site, at the mine site, and then tanking water out to a production site where we would produce the propellant with a higher power need there to convert that water into hydrogen and oxygen, and then there'd be the customer site where you'd need to transport that product. So this was kind of the bigger architecture that we used to try these criteria out. Next slide, please. Just to say, this is kind of where we set those ground rules for the initial criteria. Again, you could go into that study and look at it in greater detail, but you can kind of get a feel for the distances we're talking about with the conventional needs. You can see that, that's in those first couple criteria with the slopes, and then you can see our tonnage kind of criteria with the mine size and the ice stability as we know it or as we can estimate it now. Again, that's a big open question. And then again, sunlight played a role into that for illumination, for the power. So all of that rolled into the analysis, and that's really our criteria. Nothing there's a big surprise other than again stressing that the smaller PSRs here kind of fell out of this study. Go ahead to the next slide. I don't think I want to spend much time on this. This kind of reworks the data again, if you're interested in looking at it. But we're looking for this sort of overlap on that Venn diagram of all these different things. So there is a little different perspective here. And go ahead to the next slide. Let's just get into some of the. So I'm not going to go through these in great detail, other than to say we did do an evaluation of those 6 initial sites. We didn't rank them per se, but we saw how they fell out with the different criteria. And I kind of give you a qualitative approach on how we evaluated the different regions. But that table there is sort of the punchline, where you can see that in each box, that I've kind of got each criteria and how they fell out, and the green boxes are the highest or the best in each of those criteria. And you can see one of them is the number of PSRs that are viable in each of these regions as being one of those criteria, because that gives you the opportunity or having options because we haven't ground truthed them yet. I think that's an important consideration, and you can kind of see what obviously fell out of that. Based on that, slopes, the illumination criteria, and that sort of thing, the availability, and how the different sites ranked, or not ranked. I don't want to use that word, but how they fell out in that analysis and the qualitative analysis there. So I encourage you. The slides I think are going to be made available to go back to that paper to look at that if you're interested in the more detail. But hopefully that gives you kind of the ISRU perspective and what we're considering as we move into this and what we're going to input into this process. So I think I'm pretty much at time. So I'd be happy if I don't know if you take questions now or at the end, but thank you so much for giving us the opportunity.
And we probably have time for one question. Let's filter through the chat here, Julie, and see
Right.
if there's anything interesting. Any questions for Julie? You can put them into the chat.
Yeah. The question would be: would you guys need mobile energy, like energy to do some of these, so like away from your base camp areas, like something that can be taken to and from for electricity?
Energy, of course, and power availability is a key consideration for ISRU and how that's implemented. There's a couple different options for that. Um,
Right.
so, uh, so I wouldn't say it's needed, but it's an option.
It's useful. Got it.
But we'd see. It depends on where the architecture assets are for Artemis. It depends on where
Right.
we're located, that sort of thing. So,
Gotcha. Okay. I was just curious. It had it in my mind. Okay. Cool. Thanks.
For the landing site itself, Julie, like I appreciate that. This is Barbara Cohen from NASA Goddard. I appreciate that you like evaluated all of those with relationship to eventual ISRU use. But I mean, does that mean we should go figure that out on Artemis 3 or 4, or does that mean we should save them for later so that they're places that we want to go? It's still not clear to me whether it's in everyone's best interest to go to the same location or a similar location over and over again, or if we're really trying to go to different areas every time.
So I think, Barbara, that consideration is still something being discussed, right? If you put down an asset in Artemis 3, is it going to get reused? Is there potential for reuse? Do we want to do that? And I don't think that decision's been made, but having that opportunity, at least talking about it now and talking about what that fits, I don't know that we want to go to this extent of saying let's save a site for later, right? I think there's, and the punchline through that analysis is even in those original 6 sites was all of those had ISRU potential, right? There was a way to do it. There's a possibility to do it. Some a little better than others, right? But and Sam did preface this with this sort of base camp idea, and what we need for that. So when you're starting to talk about that, that's where we come in. So again, considering this from Artemis 3, early Artemis, I'm just pushing for early Artemis. It is possible that we could leverage ISRU for at least some aspect of this. So considering that, at least when we're making those down selects, I think is important.